So now, in this video, we are on this topic about p-value in hypothesis tests, in which it has so many trivial results. So here in our example, a class found a report. Mr. Jensen told this class that he plays basketball frequently, and he claimed that he could make 80% of his free throw attempts. The class suspected that Mr. Jensen was actually less than an 80% free throw shooter. To test their theory, they had Mr. Jensen shoot a series of 40 free throws. He made P is equals to 60% of them. To see how likely an example like this was happened by a random chance alone, the class performed a simulation. They simulated 100 samples of 40 free throws, where each free throws had an 80% chance of being made. They recorded the proportion of free throws made in each sample. Here are the sample proportions from their 100 samples, which is on the graph, the circular one. The question is, they want to test null hypothesis 80% versus the alternative hypothesis, which is less than 80%. Here, P is equals to Mr. Jensen's true free throw success rate. Since Mr. Jensen had made a 60% free throw in the series of 40 attempts, since the alternative hypothesis is P greater than 80%, you can find the approximate value of this result by looking at how often a sample result as low 60% occurred in the simulation. So in the simulation, only 1 out of 100 sample have below 60%. So the answer should be .01. So welcome to this on this video, we're back at it again on p-value hypothesis testing. So in this video today is a very intriguing one. A class found out a report suggesting that a teenager's foot lengths are approximately normally distributed with a mean of 23 centimeters and a standard deviation of 2.6 centimeter. They wondered if this held true at their school. So they took a random sample of 9 students. The mean foot length of students in their sample was 24.6 centimeter. To see how likely a sample like theirs was to occur, by random chance alone, the class performed a simulation. They simulated 50 samples of 9 lengths from a normal population with a mean of 23 centimeter and standard deviation of 2.6 centimeter. They recorded the mean of the lengths in each sample. Here are the sample means from their 50 samples. So and this in the graph below. Moving on, they want to test the null hypothesis 23 centimeter versus the alternative hypothesis is not equals to 23 centimeter, where the mean is the true mean foot length. To solve this, I need your total mind and focus and concerning onto this. Thank you. For the solution of these intriguing questions, the n is equals to 9 students in the sample had a mean foot length of 24.6 centimeter. Since the alternative hypothesis is not equal to 23 centimeter, we can find the approximate p-value of this result by looking at how often a sample mean as far or farther than 24.6 centimeter occurred in the simulation. We need to look for the sample means this far above or below the hypothesized mean. The sample mean 1.6 centimeter above the hypothesis mean of 23 centimeter, in which gives us a 4 out of 50 samples, which tells us that the p-value is equals to 4 over 50 or 0.08. That will be the final answer. Thank you.